It's an honor for me to be here today. I mean, I'm a frustrated historian. I always figured if I wouldn't make it as a professor in engineering, I would become a historian, and I do that part-time anyway. So history of science, of course, is interesting, very interesting. Anyway, so I had a hard time finding a title for my presentation, so I just simply called it Tales from Our Department, an Anecdotal History of Mechanical Engineering. I do apologize for those who probably felt other things were more important in the history of our department. And there's so much, I mean, there's only a little bit of time to present this, and I'm sure I left something out. But I hope you enjoy this, this presentation. So 150 years really is a long time, right? And you already saw his photograph earlier. It's Major William Nicodemus, who was the first faculty member of mechanical engineering. And you notice he was not only a professor of mechanical engineering, but also of civil engineering. So when civil engineering already started at the UW-Madison in 1870, and civil engineering was kind of a result or a counteract of military engineering. The Civil War had just ended. Military engineering was important, and so now it became for civilians to actually also do engineering, to build the bridges, to take over what the military was doing for many years, and so that gave rise to civil engineering. And so also, that's why, no coincidence, Major William Nicodemus had been a professor in civil engineering. He was military man, and so he became our first professor. He started teaching courses in mechanical engineering, anything mechanical, and he was chosen because he understood gears and understood things that back then was really what engineering was all about. So it's 150 years of history since then. I do have to first acknowledge people who are no longer with us, but actually who shared their anecdotes with me. And if we go from left to right, the first person is Professor Ben Elliott. Actually, I met Ben Elliott in September of 1989 on the night of the awards. So a night where awards were giving. The awards were actually given in what was the old Union South. And I was quite impressed when he said, I used to live here. I didn't know who he was. Ben Elliott, of course, I mean, you can see he was born in 1889. And so he lived where now is Union South in a house. There was a house there at that time. Then he started talking about Buffalo Bill, that he actually knew Buffalo Bill. And I said, well, nobody's going to prove him wrong, right? I mean, who knows? As it turns out, yeah, he did know Buffalo Bill. And so for those of you, I see some faces that obviously knew Ben Elliott, but for all of you now, if you didn't know Ben Elliott, at least there are 2 degrees of separation between you and Buffalo Bill. So that's a good thing, at least in this presentation. That night, actually, the night of the awards, I think there was almost $70,000 were given away in scholarships. And I did check with Caitlin, this year's was $1.6 million in scholarships. I mean, there's a lot of change. This is in the last 35 years. It's a huge increase per year. So proportionally, it's more than inflation. So our department, I think, is probably one of the departments in the university that has the largest number of scholarships and money that's given away every year. And so thank you for our alumni and people who have done generous donations. So the second person from left to right is Ron Daggett. Ron Daggett held a position that I held for many years in our department in the field of plastics. And I knew actually Ron Daggett quite well. And we actually met through our wives, actually Diane, who's sitting there, and Dorothy or Dottie. They met actually in a restaurant, and for some reason they started chatting, and Dottie said, oh, so you're new here, I haven't seen you in this restaurant. I think it was upstairs, downstairs in one of those places that no longer exists. And she says, so, oh, what brings you to Madison? Oh, my husband is in mechanical engineering. Oh, you're kidding. My husband was also in mechanical engineering. So what does your husband teach? And Diane says, plastics. He said, oh my God, you're kidding. So did my husband. So anyways, and so we got together and went to their house a couple of times, and I chatted with him many times. You could find him at Perkins every Tuesday, basically until only like a couple of months when he passed away. And he had many, many stories too. There are also other stories. Another person, not from mechanical engineering, but was quite influential in mechanical engineering, and our department has always collaborated with other departments. It's not just mechanical engineering, but we have professors who, like Bob Lorenz, who taught also in electrical engineering, and so our department really has had mechanical engineering. I think is a very wide department that can actually work with many people. So anyways, Bob Bird, also I knew him for many years. He served as a sounding board, at least in a rheology book that I authored, but he also had many stories and he was a great storyteller. In fact, he called me up like the first week I was in Madison to invite me to one of his lectures. Macromolecular hydrodynamics, which I attended. I still have the notes, an amazing course. In chemical engineering. There were a lot of mechanical engineering polymer students that were there. So also thank you to Bob Bird. And finally, John Ferry. John Ferry, who was a chemistry professor, a little bit down the street towards the center of campus, who can be credited for being the father of polymer physics, but who also had a relationship with mechanical engineering and with chemical engineering and covered that territory. And I met John Ferry first at the rheology seminars, and then later we met for coffee a couple of times. One time I visited him at his home up on Summit Avenue on University Heights. So anyways, I acknowledge them for their stories and their anecdotes. And I have to somehow find a red thread through my presentation on history. So what brought me to Madison really was the manufacturing group. Madison was a thriving place for manufacturing. At the time, John Bollinger was the dean, advisor, of course, of Neil Duffy. Neil Duffy was here as a professor in manufacturing at the time. No longer here was Sam Wu. He had moved to Michigan. But between them, that whole group, Sam Wu, John Bollinger, really created from our department what became to be manufacturing in the United States. John Bollinger with controls, Sam Wu with automation. There was more. I'm just finding one word for each one of them. And Marv DeVries was here. Actually, at that point, he was for a couple of years at the National Science Foundation. But Marv DeVries is actually that gave me a phone call when I was in graduate school saying, we're looking for another plastics professor. Are you interested? And I said, well, I'm going for a 2-year postdoc to Germany. And he said, well, I don't blame you. I'd go to Germany too for a 2-year postdoc. And so I did. And I called him back when I was ready to come back to the States. And so Marv DeVries was, of course, instrumental. And he was a great person in machining and other areas. Also, Don Ermer, Mr. Quality, he was here. He basically really put down the groundwork in the field of quality and engineering economics. And no longer in the department at the time, of course, was Ron Daggett, but he had created and put the groundwork for plastics at the mechanical engineering department and engineering in general. So that year, 1989, when I arrived in Madison, the chair was Bill Beckman. Bill Beckman, of course, I knew him from graduate school. From when I was getting my master's, I took a course in solar energy, and I used his book, and of course with Jack Duffy, Neil's dad, who was in chemical engineering. Again, also a collaboration between those two departments. They had started, and you saw the solar energy group was a thriving group. Early on, we're talking the 1970s, right? They were all way ahead of their time. And so Bill Beckman was chair at the time. They had incredible parties at their house. I don't know if you guys remember, really wonderful department parties, which were very, very memorable. And sustainability really was, even at the time, was kind of a thing in our department. Our department always was concerned and was aware of the environment. And maybe a kind of forgotten name is Norman Brayton. You can see him. You can see him there, and standing in the middle of tires. He developed a cryogenic process to recycle tires, to make tires to make powder out of tires. And you can see there, conserving the future is the beginning of a paper that he wrote in I think 1973 or so. So conserving the future is something that could be today, right? I mean, this could be a title out in a paper today in our environment. Also, at the time here in Madison, and you saw him in that video, of course, was Professor John Uecker. I knew John Uecker. Many people knew John Uecker before they arrived in Wisconsin, is because he was Mr. Kinematics. We all learned kinematics and dynamics of machinery using his book and of course, in Shigley's book. They collaborated with Shigley, a professor in Michigan, but he was a very well-known mechanical engineering professor. Kinematics, of course, was also closely related to the work that Ali Sierig did. He was also here at the time. Ali Sierig had become quite famous for his exoskeleton in 1971, biomechanics. This was, and if you've been in this, I think, second floor in the ME building, you can still see it exhibited there. Is this amazing piece of equipment where paraplegics could be attached to, and they could walk with this. It was really the beginning of something big. It made world news. It was well known. Of course, he was a very well known person in the field. Also, of course, in kinematic systems and in geometry of gearing. There was a lot of controls and everything that went into his exoskeleton. And I know some of you still remember Ali Sierig's office. Right? So Ali, he was on the second floor of ME, kind of across the entrance of ME. He had, in his chaos, he could find anything. You would go and say, "Oh, Ali, do you have such and such?" "Oh, yes, yes." And he would kind of pull out a piece of paper from a big pile. And so at one point, you can kind of see here, I don't know if you can see my little arrow there. Yes, you can see right here, his graduate students found this sort of a skeleton, not a real skeleton, but a skeleton made out of cardboard, and put it kind of under the papers, and were spreading the rumors that one of his graduate students get buried under the papers, and sort of they never found them. So anyway, so that was Ali Sierig, who was also a very influential person worldwide in the field of biomechanics. So at the time, those engineering days, like the one we're here today, we would take pictures like this. This is probably a little bit before I arrived. This was, I think, 1987 or 88. And you can see on the left-hand side, Phil Myers, who was the founder of the engines research group. You can see John Bollinger standing next to him. Kind of a little bit behind him is a much younger John Mitchell. And then way on the right-hand side, you can see Ben Elliott with his legendary smile and kind of attitude. He was a short guy, but he really was a very fun person. So Ben Elliott, if you're going to put Ben Elliott in a category who actually I knew, and if you were to say, okay, what influence did Ben Elliott have in engineering, you'd have to go way back, right? So this is a 4T. He actually advised Henry Ford in the manufacturing and creating, in the manufacturing, the design of the model 4T. This one here is close to my heart because it's a 4T that has cellulose acetate windows, plastic windows, to make it a little bit lighter and to make them safer during accidents. It never made it because cellulose acetate, when sunlight hits it, it becomes yellow and then brown, and then it no longer works as a window, right? You can't look out of your windshield. But also they scratched. And it's a problem we actually really hasn't been solved. Well, I've retired, so I'm not solving that problem anymore. Somebody else is going to have to work on that. But Ben Elliott, actually, he was really well known. I mean, his obituary made it to the New York Times. Whose obituary is in the New York Times, right? Then you can see there, if you can read what it says in there. He died at 104, right? He advised Henry Ford, Mr. Elliott advised Henry Ford at the factory in Dearborn. He knew Buffalo Bill, of course, you already knew that. Um, and, and this something really interesting. He published his first book, which was called The Gasoline Engine, in 1915. So we have to put this in perspective. 1915, he publishes a book that became a classic book in the United States. And then in 1917, he finished his master's in our department. And that same year, when he finished his master's in our department, he became a professor. And so he became a professor in our department when before the Soviet Union started, so before the Soviet Revolution, and passed away after the Soviet Union fell apart. So I mean, we're talking, he really spanned many years. Well, for one, U.S. entered that same year into World War I. He went through World War II, etc. So he was, and his gasoline engine really wasn't the only one. I mean, he published many books, a whole series in McGraw-Hill on automobiles, on the electrical parts of automobiles. Was no wonder he actually was an advisor to Henry Ford. And also there's probably about 8 hours of tapings of Ben Elliott telling stories to an interviewer. I listened to all of them. Many of the stories I already knew, some of them I didn't, but he would go climb in a train here in West Washington and go to Washington, D.C. to talk to legislators. Then he would go to New York City to ASME meetings, etc. So he really was quite a guy. And the gasoline engine and why UW and our mechanical engineering department had become part of the automobile. It was really more so than the University of Michigan at the time, is what gave rise to bring in more faculty to work on engines and to work on things. And so 1946, that's the year before he became chair, before Ben Elliott became chair, they hired 2 professors, Otto Uehara and Phil Myers. And here you see them doing measurements. So they're sitting where today is the Centers building. You know, the Centers building right on next to Breeze Terrace. That was temporary building 25, which was built during World War II. They had their labs. That building still existed when I arrived in '89, and the engines group still had labs in there. But they both worked together and were best friends too, and developed techniques to do monitoring and measuring of gases in internal combustion engines. Then also in 1958, the year I was born, they attracted actually to our department Professor Ed Ovard. I knew Ed Ovard. Many of you knew him. Ed Ovard actually had taught for about 21 years at Northwestern University and was an engines guy. He wrote that book, Internal Combustion Engines, whose first edition came out in 1944. And he published actually 4 editions of that book and became really the classic of internal combustion engines, which any person working in engines around the country and around the world would use. Other people arrived and were attracted. Gary Borman. Here we have a picture of David Foster, a younger David Foster, and a younger Jal Gandhi. There's Gary Borman. And I show those 2 pictures. I didn't want to show too many pictures of current people, but the reason why I'm showing Chris Rutland and Rolf Reitz is because the 3 of us were hired that same year. We were the 3 new professors in our department. But they were hired in the engines group when the engines group became more also into modeling and other things. So they were expanding. And of course, the engines group has been instrumental in the state of Wisconsin, and small engines, large engines, etc. The engines group has been it has propelled the industry in our state. So still, when I would walk around the hallway in my first year, 1989, the fall of '89. The office next to mine, of course, was Ben Elliott, and he started telling stories. He was great at telling stories. So he started telling me the story that he is actually the one why Charles Lindbergh ended up flying across the Atlantic. It was thanks to him. And so, again, and that was corroborated later through documents through his grades. Indeed, Ben Elliott was Charles Lindbergh's advisor. Charles Lindbergh arrived in 1920 in Madison. He came from Minnesota. I forgot the name of the town, right by the Mississippi River. His dad was a senator. And so he moved to Madison. He was an only child. So he moved to Madison with his mom. First semester, his mom was here with him. He lived on Mill Street. That building still exists. It's right there. If you go down Regent Street and you're going to cross Mill Street, right, kitty cross from McDonald's, that's where his house is. That house still exists. Like there's still a lot of houses around Madison where Charles Lindbergh lived. But Charles Lindbergh saw a different College of Engineering, a different mechanical engineering department. The college looked like this. So if you take a little bit to look at that map, so if you look down here, this right here is Bascom Hill. So you have, if you look at it, so this, see here's Bascom Hall, North Hall right here, South Hall right here, and this area right here, that was the College of Engineering at the time. So first of all, where today is the College of Engineering would be right down here in this area. And so the only thing that was there at the time, it's a building that still exists, is where the Forest Products Lab was. And so that's now material science and engineering. They covered up forest products and put material science on it. But that building is where the analysis was done on the ladder that was used when they kidnapped Lindbergh's child about 10 years after Lindbergh was in Madison. So Lindbergh's child was kidnapped. Somebody went into the room of the baby, used the ladder, and so that the ladder had a broken, and supposedly the child died at that moment when they were taking the baby out. But the ladder was analyzed in the Forest Products Lab, and they were able to pinpoint where exactly it came from, what wood store, et cetera, and that was done at Forest Products Lab. The engineering building is right there. That building is today the School of Education, and we'll get back to that in a second. This right here was engineering laboratories, where Lindbergh spent a bunch of time tinkering and putting things together. Here is the hydraulic laboratory, which was part of the civil and mechanical engineering departments. It was right by the water on Lake Mendota. It's not kind of where Helen C. White Library is. And that's mining engineering right there. And of course, that was chemical engineering right at that point, also around where Helen C. White is. And this right here is Science Hall. So Science Hall, and you saw it in that video before, Science Hall was designed by mechanical and civil engineers. It was the first brick steel building in the country. So, and why did they build it like that? They wanted to avoid having more fires. So this was the third Science Hall. So the first burned down, the second burned down, and so they built this one here. And when President Lathrop inaugurated the building, he said, this is the last Science Hall, period. I think the period appeared there, right? Yes. And so if you go and look at Science Hall today, yeah, you see the Science Hall right there, and you see Science Hall, period. Because it was the last Science Hall that was supposed to be built, and sure enough, it has now resisted many years. That was the 1880s when that Science Hall was inaugurated. But back to the engineering building, that's how engineering building looked back then. This is today the School of Education. If you go, and I encourage you to go to Bascom Hill and look, they're up on the top, you see names like Rankin, like Siemens, has nothing to do with education, everything to do with engineering. So it kind of, I still think it's kind of our building, right? I mean, we're allowing the School of Education to be there, but anyhow, it's still kind of our building. Back to Lindbergh. So Lindbergh really didn't hack it in our department. So after 2 years, he was too busy doing other things. He was putting airplane propellers on boats and riding around Lake Mendota and doing all kinds of things. And his advisor, Ben Elliott, was getting more and more frustrated with him. And he said, look, Charles, you won't be able to make it in mechanical engineering. So, and you're so interested in propellers and all of that, you should just go to flight school. And so Ben Elliott sent a couple of telegrams to his contacts in Nebraska. And Ben Elliott, probably didn't mention that, was from Nebraska originally, where also Buffalo Bill was. And so he said, look, I've talked to some people that have a flight school in Nebraska. Go there. So yeah, Charles Lindbergh climbed in his motorcycle and rode through the muddy roads between Madison and Nebraska and went to flight school. Of course, the rest is history, or sort of history, right? With the spirit of St. Louis, he flew across the Atlantic, and he became a hero. He was the mechanical engineering graduate because everybody claimed him after that. He was a big hero. He was someone who was admired worldwide. He arrived here. Here he is, right here in Camp Randall, in a visit only like a month or so after he went across the Atlantic. He, of course, went back to Madison. He was grateful with Madison and what he had learned and what he had done here in Madison. And in fact, even in 1928, here's a class reunion, the class of 24. He wasn't the class of 24. He left Madison in 1922, 2 years before even graduating. Nevertheless, Charles Lindbergh graduated with us in 1924. Anyways, he's sitting right here in front. This is part of a talk that I gave when his daughter was visiting. In fact, remember I think we sat here with Roxanne and his daughter, and so had lunch together, and she had a lot of stories, other stories that obviously corroborated things that I'm telling you. So then time went on. He flew around the world. Actually, his co-pilot was his wife, Anne Morrow, who became a famous author, and actually became a person who everybody still liked. And still liked is because Charles Lindbergh then jumped in the wrong bandwagon of politics. So in the late 30s, he was part of the America First movement, had anti-Semitic speeches, etc. And once the U.S. went into World War II completely against his group and completely against the movement that he was in, he actually became a very he also went to Nazi Germany, received an award from Hitler, etc. So, I mean, there are other things which we probably don't want to talk about today in this wonderful celebration of our department. But he became a very unpopular person. Nobody wanted to recognize him. In fact, in our department, if you look at this photograph closely, it's our engineer. It's our lobby, right? The lobby, sometime in the late 70s or early 80s, was divided into two floors. So they removed the floor. They put a floor in, removed the airplane. Nobody knows where that airplane is, by the way. Some emeritus faculty had it in his garage. You know, us emeritus faculty tend to carry things away from the department when we leave. But this emeritus faculty carried a whole airplane, and nobody knows what it. Anyway, somebody said, "Well, I'm not telling you who it is," and so I never did find out. Maybe Neil knows. You don't know either, no? So anyways, but if you look closely at that black and white photograph, you see a painting on the wall, and it's a painting of Charles Lindbergh. In the 1950s, that painting was taken down. And nobody knows where that painting ended up either. They probably threw it away or something, because Charles Lindbergh had actually really fallen from graces. From a most popular person to the least popular person. But our department did adopt them again many years later. Much to my dismay, Jeff Jackoman decided to name the Lindbergh Lectures. And so, and talking with Reeve Lindbergh, his daughter, she agreed with all of this stuff. So she wasn't, she knew the history of her family, etc. So, but anyways, enough about Lindbergh. Part of the history of our department, of course. I don't know how much time I have. I don't know, still a little bit. So you see in this photograph also the three people that I probably had the most number of conversations, which are Ben Elliott, Ron Daggett, and Bob Bird. But you can see right here is Ben Elliott, and sitting right here behind, a little bit darker in the picture, is Ron Daggett. It's probably a photograph taken around the time when I arrived. That was how both of them looked at the time. They saw a different campus. Ron Daggett actually was a graduate of our department. I'll get to that. But as I said in the video, somebody wrote that for me. I just read it off. But anyways, so the department, our building looked like that, 1931. And you can see the Forest Products building right next to our building. Look at Camp Randall. Look at the field house. And then there are the baseball diamonds right there. One thing you still recognize is the UCC church right here. It was already there at the time, Breeze Terrace, etc. But that was the building and the how the College of Engineering looked in the 1930s. This is the graduating class of 1938. Look at that a group of people. There's only one thing missing there, women, right? One thing that I did notice today, of the alumni that came, there were just almost as many women as men, which is amazing. We're changing for the good, many things. Anyways, sitting right here, that's Ron Daggett, the guy with the big ears. So Ron Daggett got his bachelor's degree in 1938, and then got a master's degree in 1939, married his high school sweetheart, Dottie, and first climbed also on his motorcycle, went through the muddy roads to the East Coast, established himself, got a job with RCA, making plastic records and things, and then had Dottie follow him on a train to New York, the state of New York. He, during the war, then, since he was in plastics, he worked with Ford Motor Company and worked with McDonnell Douglas. They were making composite or fiberglass body panels to replace aluminum with fiberglass, because aluminum was in shortage during the war. And so when the war was over, he got a job offer in our department, mechanical engineering department, to teach drafting. And so again, putting it in perspective of cars, of automobiles, this is Henry Ford in 1946 hitting a car from the back using an axe, and he's demonstrating how strong composite body panels are. And so that year was important. That year, many things changed in engineering. So up until the Second World War, the physics department was in charge of teaching fluid mechanics and heat transfer. And once World War II was over, physicists were doing other things. They were doing nuclear physics. They were doing quantum physics. Fluid mechanics and heat transfer were no longer of that much interest to them. And so that's why they started hiring faculty members. They needed more faculty members. The person in mechanical engineering who was teaching, who was going to teach fluid mechanics, was teaching drafting, and so they needed somebody else to teach drafting. So they hired Ron Daggett. This is Ron Daggett shortly after his arrival in Madison in 1946. And he decided to, in addition to the drafting classes, to also start teaching a course in plastics. And that actually, if we look and see, it was the first plastics course in the world in engineering. Plastics was taught up until that point out of chemistry departments. That same year, 1946, John Ferry was hired. John Ferry, who, for those who know polymers and those who know viscoelasticity and know loss modulus with helmets when you hit your head and you need something to absorb the shock, all of that, the groundwork for all of that was really John Ferry, who developed the theory of time-temperature superposition. But John Ferry was a polymer physicist. And Ron Daggett, who actually saw the problems that plastics and polymers brought into the engineering world, he didn't understand it, but down 200 meters down the street was somebody who did understand, but the polymer physicist and the mold maker didn't talk to each other. There was nothing, they had nothing in common at the time. Nevertheless, Ron Daggett actually made a huge impact to the world. He, together with a doctor at Johns Hopkins, developed the first heart valve. There was a research project between 1958 and 1963, and the result was installing the first heart valve, artificial heart valve, in a person in a patient which had problems. Here you can see Dorothy and Ron Daggett sitting in one of the engineering affairs in our department, dressed very elegantly. I mean, I'm not even wearing a tie today, so, but anyways, it were different times. Ron Daggett really was the father of the plastics industry of Wisconsin. Wisconsin ranks now 4th or 5th of the largest states of having a plastics industry, employing people in the plastics industry, and he really was instrumental with that. For example, when Bob Cervenka, one of his students in 1955, came to him and said, Professor Daggett, you know, I got to go home. Is there anything near Phillips, Wisconsin, where I come from, where I can work in engineering? And Ron Daggett says, well, because his mom, she was a widow and she was lonely, etc. So Bob Cervenka went back to Phillips, Wisconsin, and Ron Daggett said, well, why don't you just start an injection molding company in your mom's garage? And he did. He bought an old injection molding machine in Chicago, took it to his mom's garage, and started what is today Phillips Plastics, the second largest injection molding company in the world. So that came from our department. Similar to Playcon, south of Madison, the 5th largest thermoforming company in the world. It was also started with one of his students, Tom Mose, the brother of Mose, the guy who take the cancer doctor, the Mose technique. So anyway, they were brothers. And so, but really, Ron Daggett was a mold maker. He fixed things. He always told everybody, I can fix anything except broken hearts and the crack of dawn. That was his line. And so those are the only two things he wasn't able to fix. You would see Ron Daggett around town painting. He had beautiful watercolor ink paintings. This one he gave me on my birthday in 1990. It's interesting because it's from what used to be the old engineering building, the 3rd floor, looking on Science Hall. Period. And so so if you've been in my office, you can actually see it. But the mold maker, the guy who fixed things, who actually had a machine shop in his basement, didn't really communicate with a polymer physicist. And that didn't occur until 1953. In 1953, you can see the Corvette running off the assembly line. It was the first fully composite automobile made of fiberglass. That same summer in 1953, the chemical engineering department hired Bob Bird, the one sitting in the center there. And this is a picture from 1958 where they're working on their transfer phenomena book, which really was, it changed the world of engineering and chemical engineering and material science. So because engineering now was in charge of teaching fluid flow and heat transfer, Bob Bird went a step further and he said, why don't we just have one single course, which we call transfer phenomena, where we have heat transfer, fluid flow, mass transfer, etc. So it actually saved them professors, right? and it's something for us, mechanical engineering, maybe we can still get into the transfer phenomena bandwagon. But anyways, here they are. But transfer phenomena was really put everything together in perspective. All the balances, what I call the bookkeeping, was all under one single umbrella. And you could solve problems with polymers, with models, viscoelastic models, constitutive models, etc., to solve very complex problems. And that created a connection finally between the mold maker who was interested in mold filling and the polymer physicist who was down the street. And so that connection was created when the Rheology Research Center started in 1968. You can see there John Ferry, Bob Bird, Arthur Lodge, who was a professor in mechanics. There's a viscoelastic fluid called the Lodge rubber-like liquid. Can you imagine having something named like that after you, the Lodge rubber-like liquid? Anyway, so he was also a very well-known person. Actually, the person who told us that there are not only first normal stress differences, but also second normal stress differences with complex flows, but that's another story. And of course, there's Ron Daggett, also, who now had a place where he could speak with people who were totally outside of his field. Also shows our department how we've collaborate with others. 1968 was also the time when the engineering research building was built. You can see also the engineering hall there. Engineering hall was 1948. The west part was built in 1964. The east part, and they're both E-shaped for engineering. I don't know if you've seen them from the top, but there is a reason why the buildings have that shape. But if we go back to engineering research building, to some of you it may look really ugly, but there's a reason why that building is like that, and that's because it was modeled after a Fortran, a 72 column Fortran punch card, right? It doesn't have 72 floors, but the windows are randomly located around to emulate a punch card. So anyways, it's very dated, but it is true. And I don't know, I think I've heard somewhere that they were going to demolish that building, but anyways, so at least until, well, it's there, you know exactly a little bit its meaning. The campus really has changed, right? And the College of Engineering certainly has changed in the last 150 years. I have this picture here. It's a little older picture. It's like 4 years old. Because if we have a view from the top, you'll see a lot of construction happening, which is progress. This is what's happening, right? So there's more coming, more being built, etc. But you can see our beautiful College of Engineering here in the foreground with Madison and the university on the other side. So many things really happened since 1875, since Major Nicodemus founded our department. It has changed. It's much bigger. I don't have a photograph of our department more recently. This one here is from 2022. It's bigger now. We should take a picture for the next talk, but I probably won't be here for the 175th one, but anyway, somebody else. I'll leave the slides for the next person to enhance the presentation and to add something that I left out. And again, I do apologize that I left things out. But our department now has 79 people. I mean, this is amazing, right? I mean, we have a great department. There are 16 staff members, and it wouldn't work without the 16 staff members. It's kind of the oil in the machine. It makes everything work. It makes everything turn because it's so big. I mean, we have 51 tenure track faculty. When I arrived, there were 30 in 1989. And more impressive is there are 18 full professors and there are 18 assistant professors, which means we are going to fill in the blanks when people like me retire, and there are people coming up the ladder to fill in, and hopefully a lot more assistant professors. But there's teaching professors, which are not counted among them. There are instructors, etc. So our department really, really has moved in amazing ways in 150 years, and I thank you. Normally I stand to answer questions, but this is not that kind of talk.
Thank you, Tim. It was a wonderful review of history. I learned a bunch of little factoids that I'll try to reuse. So, thank you all for attending today. IAB, don't disappear. We got work to do yet this afternoon. We're meeting with the dean, and they have questions for you, Devesh. So be ready. But again, thank you for attending. One, I guess, announcement is we did put up a history wall in the south entryway of the mechanical engineering building just beyond where the gears are. So I'd invite you to go over and take a look at it. It includes some of the things that Tim covered in his talk and is in that video and little stories about it. So nice recognition. And we also, there's a lot of stuff on current students and current projects, which when we think about the 150th, it's fun to look back, but we really need to be looking forward and how we continue to remain relevant. And that I think we have a lot of people committed to doing that. So anyways, thank you all for attending, and see you next year.